Okay, so what we're doing today is we're starting chapter 3, which starts to dive into functions. And there's a lot of learning targets for this chapter, but today the learning targets we're going to be able to talk about is whether a relation is a function. We're not really focusing on linear or nonlinear today. We're also going to be able to find the domain and range of a function. And we're also going to be able to determine which variable is independent and which variable is dependent. Okay, so we got lots of different vocabulary words. Ooh, look at all that. Okay, and so the first thing we need to know what it is a relation. And a relation is just a set of ordered pairs. And just remember that ordered pairs are just coordinates. Which is your x, comma, y. So a relation is any set of ordered pairs. It doesn't matter what it does. It just means that there's a relationship. Okay, so the domain is the x value, which is also the first value. And sometimes if you're looking at a table, it's either on the left or it's on the top. But the first one is usually domain. The domain is also the independent variable. Okay, the domain is the controller. The domain controls everything. Okay. The range is the y value, which is also your second value. The y value is also sometimes on the bottom or the right when you look at tables. The domain or the range is the dependent variable. So the range is going to depend on whatever the domain tells it to do. Okay. So what I'd like you to do first is we're going to kind of take our notes in sections. So I'm going to give you 2 examples, and I want you to copy them down, and I want you to find the domain and range. We'll get to the next part in a second, but right now, I just want you to copy the problems down, list the domain and range for each one, and then when you're done, press play again so you can check what you got. Okay, well, hopefully you're back. The domain, remember, is the first variable, so it's my x's. So I have a 5, I have a 7, I have a 3, and I have a 6. So that's my domain. My range is my second variable. I have a -2. I have another -2, but really I already wrote it, so you don't need to write it again. I have a 1, and I have a -8. Very good if you got that. All right, looking at the second one, again, my x, 4, -2, 5, and 4 again, but I already wrote 4, so I don't need to write it again. Range, 1, 3, 1. I already wrote the 1, so I'm not going to write it again, and -2. All right, so you know now what domain and range are. Let's go ahead and let's go a step further to figure out what it means to be a function. Okay, so a function is where each x value goes to exactly 1 y value. Okay, what happens is x cannot go to 2 places. X cannot go to the house and to school. It cannot go to 2 different locations. This does not work, okay? X always has to go to the same place. Sometimes you're going to see something f of x. I'm just introducing it now. I don't want you to get thrown off with f of x. F of x just means y. It's a function of x, meaning whatever x is, that tells me what y is going to be. Okay, so another way, the best way to kind of see this is to look at examples versus non-examples. Okay, so a function, let's make up a function. 1 with -2, 2 with 5, 3 with -6, 4 with 5, and 1 with -2. So what happens is if you have the same x, it must have the same y. Same x must have same y. So I look at my x's. Oh, and I have the same x. So when I have the same x, I look to see what it's paired with. And if you notice, both of those x's are going to -2. They're going to the same place. And so since they go to the same place, that one works. It's a function. Now, sometimes what you're going to have is you're going to have something called a mapping, which is kind of bubbles. And what they do is they put these in order from smallest number to biggest. And they also make sure that they don't repeat numbers. So my smallest number is 1, then 2, then 3, then 4. And these are my x values, which are also my domain. And then I have my y values. My smallest y is -6, -2, and 5. So these are my y values, and these are my range. Where a mapping is a great way to visually see if something is going right. So what I do is it says 1 goes to -2. So I draw my arrow 1 to -2. And then it says 2 goes to 5. 3 goes to -6. And 4 goes to 5. It has this one again, 1 to -2, but I already drew that arrow, so that's okay. So if you notice, each of these x's only go one place. It doesn't matter that 2 of them come here. What matters is that each x goes to one location. So here's an example of a function. Okay, so now let's look at a non-function. -3, -4, -2, 6, 5, -1, and 3, 2. So again, you look at your x's. Oh, and I see some common x's. I have -3 going to -4 and 3 going to 2. X cannot go 2 places. It's like saying one person can go to 2 parties at the same time. You can't do it. X cannot go to 2 different parties. Okay? And so when we draw the bubbles, you'll see it. It'll make a lot of sense. My smallest is -3. Oops, I forgot the negative there. If you were getting confused, I wrote it or was thinking it, but I didn't write it. And then what's the next one? -2, and then 5. And then my y values, -4, -1, 2, and 6. And so 3 goes to -4, 2 goes to 6, 5 goes to -1, and then 3 goes to 2. -3 goes to 2. So you notice here, you see how this guy's going to 2 places? You can't do that. So that's what makes it not a function. Okay, so let's look back at these 2 examples we had earlier, and let's figure out if those are functions. So take a second to look at the x values, and if you have x values that are the same, then check to say that the y is the same. So I have a 5, a 7, a 3, and a 6. So this one's a function. It works. It doesn't even matter what the y's are. You just start by looking at the x's. So the second one, I have a 4, a -2, a 5, and a 4. Uh-oh. Are they both going to the same place? No, they're not. One's going to 1 and one's going to -2. So this is a no. And by circling them and crossing them off, that's why 4 can't go to 1 and -2. That's all you need for a reason. You just have to describe what happened. All right, another way that you could tell if something is a function is something called the vertical line test. And I learned this from a teacher about 10 years ago. And what she used to say was she would say that she was dropping bombs. When you drop a bomb, We do not have high-tech bombs. We have old-fashioned bombs. You drop them, and it's a vertical line going down, and these bombs only blow up once. So what happens is you drop a bunch of bombs. And if a bomb blows up more than once, well, guess what? It doesn't work because we are not that high-tech. Okay, so you have to help me make the bomb noise, which always sounds funny. But I drop a bomb. Okay, that's good. That one only blew up once. Wasn't very straight, but you get the point. But if I come over here, pow, pow, okay? Funny bomb. It blew up 3 times. So since this bomb blew up 3 times, this is not a function. Okay, so I look here. Everywhere I go, it only blows up 1 time. Doesn't matter where I go. So since each bomb will only blow up 1 time, this is good. This is a yes. All right, this last one's a little tricky. I'm going to blow it up. That's okay. That's okay. This is the one right here that I'm not sure about. If I blow it up from the middle, it blows up here. But you see how this is an open hole? It's like a black hole. It kind of misses it. It doesn't go through it. It just goes through it. It doesn't touch it. So since it only blows up here, it can't blow up here because that's an open circle. And so this is also a yes. Okay, so remember dropping bombs. Sometimes it's fun to make bomb noises, but bombs are not high tech, at least what we have, and they will only blow up once. Okay, finally, let's go to our last examples. This time we're going to be talking about the independent and dependent. Please remember that the deep independent is the one that controls. Independent controls everything. So if you could figure out the controlling factor, then you could figure out what the independent variable is, and then the other one has to be the dependent. So number 3, why don't you go ahead and write both of those down so that when we're ready to go over them, you're ready to write it down and follow along. So the amount of gas you put in your car affects the distance you're able to drive. So you have to ask yourself, what's in control? Well, it says the amount of gas is what's in control. So your gas is your independent variable. And it affects the distance you're able to drive. So distance is the dependent. Okay? Why don't you look at number 4 and see if you can figure out which one's in control? Did you figure it out? Your current data usage is based on how many videos you watch. So this one, the usage is based on videos. So videos is in control. So your videos is the independent variable. Well, that number of videos controls your data usage. So your data is the dependent variable. So there's a lot of different types of problems here. I recommend you go back through your notes. Remember, domain is X, range is Y. And a good way to remember that is it's alphabetical. Okay? And then whether or not it's a function, remember X can only go one place at a time.